So this is about the SPG binder spec. Show of hands, who was next door in the last session? Quite a few, not all of you. Well, that's good. If you saw Amy's talk on that, this is essentially the same talk with a few tweaks. But yes, we did coordinate message. We want to say the same thing when we talk about this. But we've talked about this a lot, so we've kind of got it down. We know what we're going to say and all that sort of thing. So I'm going to talk about the SPG, the Surface Performance Graded Binder Spec. And this is something that we've been working on. We've been trying to roll out, get trial projects out there, and try to implement. And it would be a replacement for our old binder spec. And I'm going to kind of go through the same type of topics that she did. We're going to talk about why. We're going to talk about how it's developed over time and how we validated that specification, and what our current specification is, because we've made a few changes from the last couple of years. We're still evolving this thing. And then how you select binders for that spec and kind of what our goal is. So as we go through that, hopefully I can clarify any issues you have, but let's go right into it. Now at this point, I'm sure Amy looked at the presentation she had put together and said, what is he doing? Why is he putting pictures of trailer parks and stuff in here and all that? And I said, I'm always trying to come up with a metaphor, some way to explain why are we trying to go to SPG? Why are we working on this spec? And one of them is this. These are things you might see in a big town, small town, in the suburbs, any place where there's a very old neighborhood. People bought these big lots years ago and they put a trailer house there because maybe that was all they could afford, or maybe that was the only thing they could get in the time frame because they needed a place to live or whatever reason. But over the years they expanded them, right? So you see somebody put a deck on one right there, built on an extra room. That was probably a garden room originally, and then they built it in to make a bedroom for a kid that wouldn't leave home. And then they built a garage, and then that turned into a shop, so they built the carport. That turned into a built-in garage, and they built another carport and expanded and expanded and expanded. And that's fine. In fact, these examples here, they look like they did a fairly good job of it. Sometimes they don't, but that's something that happens. And you can do that, but if you keep doing that too much over a long period of time, it can sort of get out of hand. And this can be where we end up with our binder spec, because we started out with penetration, right? That was our trailer house. And then over time, we added things to it as new technologies came along. Pen was the state of the art at the time when they first came up with it. We added things onto it. We added viscosity. We added some PG-related tests at times. We added polymers at some point and came up with emulsions and added more things into the spec to make that work. But we never really built a new house. We just kind of kept adding to the old house. And so that's what happens after a while. You're trying to live in this thing, and maybe this thing does have a certain amount of charm, you got to admit. But if you're trying to maintain it, you're trying to work on it, and you're trying to add anything else to it, it gets really difficult because it's not systematic. Everything is a hodgepodge, and it's very difficult to understand. Eventually, you need to tear that down. You need to build a new house that incorporates all the features that you want in a rational way. And that's one of the things we're trying to do with the SPG spec, is make it rational, make it make sense to us. And so that's kind of where we're headed with that. Another thing is this, I've got an airbag recall right there, and what does that have to do with this? Well, I got an airbag recall on my pickup. You need to come in and let us replace the airbags, and I haven't done that yet. And so the question is, why not? Well, it's a pain to do that. You've got to get the truck, you've got to schedule an appointment with the shop, which they don't really take appointments. They just want you to show up at 7:30 in the morning so you can wait 3 hours and hopefully somebody gets to it before lunch, which means you've got to drop it off, you've got to get a ride back to work and all that sort of thing. And it's easy to put this on the back burner because the truck drives fine. I'm not having trouble with the truck. Why do I need to go have the airbags replaced? And sometimes that's what I feel like talking about this spec is, we've got a good seal coat program. Why are we messing with it? Well, we don't have a good seal coat program because we have a binder spec that guarantees a good material. In fact, our spec leaves a lot of room to get bad materials, and we have good materials because most of the time we have good material suppliers. and we have good contractors and usually have a good seal coat program. So we don't really need this airbag until we need it, until somebody shows up that's not doing the right thing. And then our spec has giant holes in it. And so that's another way to look at it. And then I was talking to somebody from one of the districts on the phone and about this spec, and they said something that I said, that's a perfect way to explain this. They said, we get CRS2P, that's a spec for a product. Okay, that has nothing to do with what it's used for. That doesn't say that it's a material for anything in particular. It's a product, you know. It's CRS2P, HFRS2P, Coke versus Pepsi, right? But if you go to that CRS2P and it fails the viscosity, for instance, well, that property doesn't really tell you that it's right for the application. If it's supposed to be 1200 and you get 200, well, you know you got a big problem, because that material is super soft and you'd be surprised if you don't have trouble with that material. If it's supposed to be 1200 and you get 1150, what does that tell you? Does it tell you it's a bad material? Not really. Does it tell you you're going to have trouble with it? Not really. What does it tell you is just that it's not exactly that product. And so we need to get to where our properties that we're measuring on the material mean something to us, and not just indicate that it's a particular product. And that's kind of what we're trying to do. So I don't know if that landed or not. Those are kind of my crazy ideas for metaphors for our SPG binder spec, but that's kind of where we're going. So this has been going on for a long time. The evolution of the spec is that we've been doing research for, 17 years since the first project that Amy was doing the research on. We developed this spec. We did some trials. We had some more research over the years. There was national efforts on this. We took it to ASTM in AASHTO and didn't get anywhere with it. But we kept working on it because we knew this is something we wanted to do. And so we've developed this over time. And the idea is that this would be, you know, a replacement, again, for our current binder specs, which are not specs for seal coat binders. They're just specs for binder. But we want to have a spec that's actually targeted at seal coats so that we can get precisely what we want. And this slide shows that basically from 2001 to 2016, we've made a lot of changes to the spec. And you see some things in there where we didn't have a property that we measured of some kind, and we added it in there. And then later on, we changed our mind because we didn't think it really was telling us anything and took it out. We had other stuff that was in there from the beginning that we removed because it didn't correlate with the performance, like the M value from the bending beam rheometer, if you're familiar with that test. And even, you see the last two columns, 2015 and 2016, that's in the last year that we have made revisions to that spec based on the data that we've got from the testing we've done in the field and from the round-robin testing we've done. So we've been revising this thing, refining it, polishing it for all that time to try to make it as good as we can before we get ready to go and try to implement. And that's kind of what this process has been about. So when we validate the spec, we've done a lot of sections. Basically, what we realized early on is we can make, because of the way the spec works, we can make every section, every seal coat job a test section. And the process is, well, the first thing you do is right up at the top. We collect the binders from projects that are being built. And then you go over here to the left side, laboratory characterization. That means we're going to take those binders, whether they specified SPG or whether they specified a traditional binder, we're going to grade those with the SPG system and come up with a climate range, because that's what the SPG system represents, is a climate range where that binder should be good for. And then we're going to look at the climate data for that location and make a prediction about whether or not we picked the right binder for that location. Then we're going to monitor that test section over some period of time, usually a year, and look at how well it did and categorize it very systematically. We're going to come up with this surface condition index, that's what that SCI in that slide stands for, and see how it did. And then we're going to bring it back together and compare the two. How did we do on our prediction? Did we call it right or did we not call it right? And over the years, we've done pretty good. So typical results from stuff we've done, anywhere from 70 to 80%. agreement with our predictions. And what that means is when we said the binder would be a good binder for that project, it was. When we said it would be a bad binder for that project, it was. And so that's what that agreement means. The disagreements are where those don't connect. We either said it was going to be good, but it failed, or we said it was going to be a problem, and there were no problems. Now, what does that mean when we miss that prediction? Well, it could mean that we just missed on our selection. We picked the wrong grade, our parameters are not in quite the right place, which means we need to go look at our spec, see if we need to make adjustments, and see if we can correct that. And as you saw from the slide before, that's what we've done. We've kind of made those corrections over the years to address those things. Sometimes we can go look at the project and find mitigating factors that explain why we had that disagreement. Like when we say a binder is not a very good binder for a project, and it's way off base for the climate selection, and we go out and find that it performed perfectly well, but there were only 500 cars a day on the pavement, and so anything would perform under those conditions. Sometimes we say it would be a great binder for the project, it falls apart, and we go out and find that there were some workmanship issues that absolutely caused it to fail. So sometimes we miss just because of that. But we've done a lot of sections, we're continuing to do more sections. So here's what the spec looks like. And basically, if you're familiar with PG binders, you know that this looks just like a PG binder spec, with some small differences. Now at the top of the deal there, you see the high temperature grade, and underneath it the low temperature grade, and then the typical tests like you would have in a PG binder spec. DSR, bending beam rheometer, those are the key tests that we're using. The key difference is that when you look at those grades, and for instance right there below where it says SPG 73, it goes 13, 19, 25, 31 on the low temperature grades. It's the same way on the high temperature grades. It used to be in 3-degree increments, so there are twice as many grades. And after looking at our round robin test results and after looking at the grades we were selecting in the field, we decided that it was a lot better to go to 6-degree increments because one, we didn't really have the selectivity to do that, and two, it really made it a lot more complicated to choose your grades. So the grades are in 6-degree increments, just like the PG binder spec, the grades are in 6-degree increments. Instead of going 64, 70, and 76 though, we're gonna go 67, 73, and 79. So they're offset 3 degrees from what the PG binder spec is. And that way, you don't have that overlap. If you see a 64 minus 22, that's a PG binder because that grade doesn't exist in the SPG spec. If you see a 67 minus 19, that's an SPG binder because that doesn't exist in the PG spec. So we did that just to set those two apart from each other. The other thing that we did was that we looked at the phase angle, and we had a lot of discussions with the industry, particularly with emulsion manufacturers about the phase angle. The phase angle is a test to make sure that you get polymer into that binder. And they felt like they were going to have trouble meeting it, and in particular, they were going to have trouble meeting it with materials that we already use and know work for us, like CRS2P, for instance. And basically, after looking at a lot of data and looking at a lot of the materials we got, we decided that we're going to increase that a little bit for emulsions, make it a little bit more permissive, but because of the data we've seen, hopefully we're still going to get polymer modified materials where we want them. In the meantime, we're still looking at other methods to verify that we have polymer in there, such as MSCR test, if you're familiar with the binder testing, and that sort of thing. So we're still not 100% set on this. We're still evaluating that spec to see if that's where we want to go, but we did make an adjustment for that. And then, and that G-star over sine delta, that's just for emulsions, if I remember. No, that's for everything. Okay, so we adjusted that a little bit because we did see some problems in the field with some binders that were a little softer than we wanted. And again, we're just making adjustments for what we saw. We think this will work out better and get us more where we want to be. That's the same as it's been, but the temperature ranges, the temperatures that we're selecting are different. And so then here's the slide where we compare the PG binder spec versus SPG. And without going through all of these details, just to say we have the same testing, the same test methods that we're using for PG and SPG, and we're running those, but we're looking for different values of the parameters we get out of them. And the reason for that is the PG specification is designed for hot mix. It's designed to look at the behavior of pavement when you're concerned about things like rutting and thermal cracking, and it's designed to look at the temperature of the pavement a certain depth under the surface. We're not doing that for seal coat. We're trying to make a spec that addresses seal coats, so you're concerned about the temperature right at the surface, and you're not concerned about rutting or cracking because seal coat doesn't do anything for those properties. We're concerned about flushing and chip retention. So we're targeting a spec right at seal coats, and that's why it's a little bit different. And the key thing to remember is because we're looking at different parameters, the properties of the materials don't correspond. So if you have two materials that are real similar, say a 64 minus 22 PG binder and a 67 minus 19 SPG binder, even those climate ranges are similar, the properties of the materials are not necessarily similar, because for the same climate, we're going to use a little bit different binder for seal coat than we would for hot mix, and that is what we're getting out of that. So here's a little color-coded thing that I put together to kind of talk about the type of test we're using to evaluate the material. And I'll start right there at the yellow, assurance of sprayability. So this is tests that we run to make sure that we'll be able to spray the material through the distributor. Oh, and I've cut off the top. These columns represent different binders. So you've got what I can see that you probably can't is the first column is 15P, then 10-2TR, then 25TR, and then SPG in the rightmost column. And so I'm just comparing the different binder specs and the tests that we run. So for all the AC binders, we run a high temperature viscosity. And we're still going to do that for SPG. So nothing really changes there except the temperature where we run the test. In the green, we're talking about whether or not the binder is resistant to bleeding. And what we used to do is we'd run a viscosity at 140 degrees, and in some cases we'd run a DSR to make sure we have enough stiffness at that high temperature. With SPG, we're doing away with the viscosity and just using the DSR, but we're still measuring the stiffness at high temperature. So we're not really changing much there except the temperature at which we run the test. Down in the purple, we're talking about the low temperature properties. Now the old-fashioned AC spec would not have anything in there because we didn't run any low temperature tests. Over time, we had some PG properties that crept in there, which kind of represents SPG kind of sneaking into things in an early sense from way back. But we would run a DSR, we'd run a BBR test, which is designed to identify cracking in hot mix, but we would use that to make sure we had good low temperatures for that binder. Well, we're still doing that, and we're adding that in some cases for SPG binders, so we're getting that. And then you've got your stuff in blue as your penetration and softening point, which are essentially just old-fashioned tests for the consistency of the binder. They're not really telling us that much anymore. The DSR and the bending beam are much more informative tests. We're ready to do away with those old-fashioned tests and move to more modern stuff. And so everything from the yellow down, there's not that much argument over. There's argument, but it's over where should the spec limit be, what are the details of the procedure, all stuff that we can work through, and we're working through that with industry. Up at the top is where all the argument is, okay? Because in the AC spec, we say you're going to have this kind of polymer and this much of that polymer. In the SPG spec, we're not doing that. We're doing it the same way we're doing the PG spec. We're saying you can put any kind of polymer you want in there or no polymer, but we're going to have a test to verify that it behaves like it has polymer in it. And that is what all of the argument over SPG spec is whether we're going to require that polymer in there or not. We still think we're going to get that polymer because of that phase angle test, but we're just not telling them what to put in there. We're not telling them the amount to put in there. So that's kind of the comparison between what's new and what's old. Then when you look at emulsions, you see exactly the same thing. The stuff in large letters is the stuff that applies specifically to emulsions. And the key is that for the whole emulsion, when you run this test for stability, like demulsibility, when you run the viscosity, And when you look at the composition, in other words, how much asphalt it's got to have in it, we're doing all the same tests we used to. It's only the residue tests that are changing, and they're changing in the same way that ACs are changing. So to select a binder, we have a process that we kind of walk people through when they go to select an SPG binder. And there's the 4 steps, and just to talk about each one, we can first go to the simplest, most quickie selection possible is to look at a map. And we'll have a map that shows different regions of the state. In this case, you've got 5. This is under last year's spec. So you pick your region, and that tells you what binder to start with. And that's your starting place. If you want to be more detailed, you can do other things. Oh, this is the new spec where we went to the 6-degree increments. You can see it's even simpler now. So this gets you your starting place for your binder. Or you can get more detail by using a spreadsheet program like this one that I wrote. There's a link to this in the pavement design guide on TxDOT's website. You can pull this down, or you can ask me for a copy of it if you want to use it, and that will help you select your starting grade for the climate that you're working in just by putting in your county or your longitude and latitude. And it also works for PG binders if you want to look at that as well. So I built both of them into there. Then you make adjustments, possibly. So just like with the PG spec before it, you look at your traffic conditions. And if you've got heavy traffic, you've got a lot of curves or a lot of turnouts or something like that for a seal coat, and you feel like you need more performance, you can bump that grade up. You can widen that grade out to deal with the issues that you think you have. And in fact, most of the time we recommend that you do that. And then you can go and look at the grades you've gotten before and say, well, how did they grade out in the SPG system? And is the grade I've selected make sense to me in terms of what I've used before? And if the answer is no, you might make some other adjustments and select your grade. And if that seems complicated, hopefully if we walk you through it, it won't seem that complicated. We'll try to make it as easy as possible. But remember, we did all this with the PG specification back in the 90s. We would walk through this process to select a binder based on climate and make those adjustments and that sort of thing. And after only a few years, we figured out what binders work for us. And we don't go through that process anymore, do we? We just pick the grade that we know we use. And so this gets us started using the spec, but this is not something we have to go through forever and ever. Of course, we monitor performance on test sections, and we try to do these visual surveys, and the researchers doing this have had the same guy out there doing the monitoring on every one of these sections, so we try to get very consistent observations and evaluations of those conditions. We do them after a year in service because the opinion has been that anything that lasts, most of your problems with chip seals are going to show up within a year, and we find that that's been pretty much the case. But that's how we've done all of the stuff up to this point. And then we've also kind of run the propaganda machine to try to get the word out as much as possible. And part of this has been at the request of the industry. They really wanted us to come out and communicate this and get as much detail out as possible. So we've really tried to go to TxAPA as much as possible. We've tried to go to AGC and keep them up to date on what we're doing, involve them in our projects and our round robin testing and all of that sort of thing, get all of their input. And then Amy and I have both, Amy much more than me, have traveled around and talked about this spec at other meetings, national meetings and that sort of thing. So we're really trying to make sure everybody knows what we're doing. That's why we're here. I guess, you know, we said at this particular meeting, you realize that, well, this session has got the same topic in it, and everybody said, well, yeah, that's okay. So evidently they thought it was important enough to talk about twice, which is why I'm here. So we had a round robin. We kind of did that because we've got some new test methods in our spec. And we've got some test methods that are old test methods, but we're getting different parameters out of them now. So we wanted to evaluate that and make sure that when we go to test and the industry goes to test, we get the same results. So right now we've done one complete round of round robin testing. We're in the process of finishing up another. to evaluate how well these tests work and how consistent they are. And they've looked really good so far. There have been a few surprises, like, for instance, if you're running a DSR test, that should be more repeatable than running a DSR test after a recovery step, right? Because the recovery step throws more variability in there. Evidently, that's not the case with this one. But, you know, we're still looking at some of that stuff. But this has helped us make sure that we're doing a rational thing with our testing, and it's helped us make it uniform so that everybody understands exactly what they're supposed to be doing. The effects of the SPG, well, if you go back to my rationale, all my goofy pictures of trailer houses and Coke and Pepsi and all that sort of thing, the effects of it hopefully are going to be that we have a rational spec, that we can look at those properties and go, we know we chose those properties for a reason. We didn't just pick a product off the shelf and say that's going to work for us. And all of our binder grades will be on a common currency. If you say it's SPG umpty-ump, well, that should be the same performance regardless of whether it's an AC or an emulsion, cationic, anionic, high float, you know, you name it. That should work for whatever climate you're using it in. And so then the spec makes more sense. It's easier to know what grades you can substitute for other grades. It's easier to diagnose problems and that sort of thing. So that's what we're trying to get to. Currently, we've got the tier table. This was mentioned a little bit in the previous talk, is that we've had the tier 1, 2, and 3 asphalts, and I have proposed that almost using the grade selection system that we've got kind of takes the place of the tier table. So your climate selection is almost like a tier 1 asphalt, and then as you bump that up for the conditions, you're going to a tier 3, and then you're bumping it up to a tier 2 and a tier 1 to get better performance. And so this spec lends itself to that kind of approach where you're optimizing your binder selection for your project. So what are the challenges? Well, the biggest challenge is always change, because this process is not going to be without some pain. But we want to minimize that as much as possible. We do have a new recovery procedure for emulsions. That's brand new, and we're working through details on that. All it looks pretty good. It requires the bending beam and the DSR, which is not a big deal for those AC suppliers, because they usually make PG binders as well. They've already got this equipment. The emulsion manufacturers have not necessarily had to do that before, so there will be some ramp-up issues with them getting the equipment they need to have, and making sure we pick the right grades. If we don't pick the right grades, we're in trouble. And again, the specific polymers and that sort of thing are one of the issues we got to work through. And I was thinking I might put a picture of a giant mansion here to say this is what we're going to replace it with, but then I said, that's not realistic yet, okay? We're not solving every problem with our seal coat binder spec. We're trying to modernize it. We're trying to get a house that makes more sense, that everything is built for the same purpose and that sort of thing. What'll happen is we'll build this new modern house, then we'll start tacking things onto it over the years, and after a while, we're going to want to tear that down again and replace it with that mansion. But we're not quite to that point yet, so I wanted to be realistic with that. And so there's the contact information for Amy Epps Martin. She's been our key researcher on that and did the presentation earlier. And of course, if you've got questions about this spec, or if you want to do some work with it and that sort of thing, you can always call me as well. And so I'm available. And I noticed also that we were listed as Jerry and Darren on the agenda, but I did all the talking. So Darren, what did you want to add to this whole thing?
We're looking for volunteers. And so I know that lots of people's seal coat plans are going to letting in the next few months. Some have already gone. Some of you have chosen to use the SPG spec, and some maybe didn't know that you could, or didn't have the experience, or you just did what you did last year, and you didn't use it last year. We're encouraging people to use it. If your plans are already underway, grade to select. You have several choices for getting that information.
I think Amy was just saying special provision 300-011. Is that's the special current special provision for that? And Darren says encouraging, but I'm going to revise that a little bit and say we're kind of begging for volunteers to help us implement this spec, to help us improve this spec by getting some projects let with it out there.